Hello everyone, I am John Paul D. Alolor and I am here to discuss all about lasers, its characteristics, and how laser works. Laser is actually an acronym. It stands for Light Amplification by Stimulated Emission of Radiation. Nowadays, it is so common that people don't bother to capitalize it and simply write laser. So why are lasers useful? Why are they ubiquitous? The answer can be broken down to three unique properties the laser holds. The first being line width. With the pure tube laser, referred to as the line width, can be quite narrow, more so than any other light source. In layman's term, this is a measure of what frequencies are contained in the emitted light. The narrower the line width, the closer the emitted light is to a single frequency, single color if you will. Thus, a laser is said to be monochromatic. In reality, it does output a small range of frequencies. The smaller this range, the better the line width. The end quality of the laser, in contrast, an incandescent bulb has a very large width and emits a broad spectrum, which is why the emitted light is white light. Is a superposition of all the colors in the visible spectrum. Having a narrower line is useful because many scientific experiments want to analyze stuff with certain energies. Different wavelengths of a light corresponds to different energies, hence having a source with one energy is helpful. The second is coherence. The light emitted by a laser is coherent light. This means it is all polarized in the same direction as well as being in phase. The laser is said to output highly coherent monochromatic light. An LED, on the other hand, is also monochromatic, one color but it emits incoherent light. An analogy with synchronization and harmony can be made. Imagine an orchestra playing. If the orchestra is in sync and everyone is playing the parts correctly, it will be pleasing to the ear. The laser, if some players are playing out of sync but still playing the parts correctly, it won't sound as good. The LED coherence is important because all the photons have their energies together, and we can then focus them on a small spot over some distance. Lastly, power. Lasers make it possible to deliver a high intense light to a small area. Of course, militaries are particularly interested in this aspect of the laser, as well as medical applications, laser eye surgery for example. Now let's take a look at how a laser works. The stimulated emission of light was a discovery by Einstein around 1916. All we need is an atom which possesses the electrons just like any other atom in our world, and a photon that is a quantum of light. The atom has electrons orbiting the atom's nucleus. For better understanding, the Bohr model of the hydrogen atom will be used. The hydrogen atom has only one electron. The atom and the electron on the ground state, namely E0. However, an electron may have other discrete values of energy. For this example, two energy levels will suffice, E1 and E2. And the electron can be excited to a higher energy level by absorbing a photon whose energy is equal to the energy difference between the levels. The electron is said to be excited. However, after a very short time, the excited electron will go to the lower energy level by emitting a photon equal to the energy difference. This is called spontaneous emission. But when an atom absorbs a photon and after a short time, another photon is absorbed, a stimulated emission will be the result. The newly created photon has the same phase, frequency, polarization, and direction as the second photon. So it's a copy. The operation of lasers is based on the process of stimulated emission. Here, we will discuss a three energy level design. A photon is absorbed by the atoms. The photon has enough energy to leave the electron from energy level E0 to energy level E2. Shortly afterwards, the electron jumps into energy level E1. This can occur with the emission of a photon. A laser device is made up of several components. First of all, a mirror with the reflectivity of 100% is installed at one end of the device. Furthermore, we need a gas or a liquid or a solid that serves as the gain medium and it creates identical photons. Another mirror with the reflectivity of about 98% must be installed at the other end of the gain medium. Another part we need is an energy source in order to use photons to raise electrons from a lower energy level to a high. One process is called optical pumping. Now, let's have a look at the inside of the gain medium. The atom and the electron are on the ground state. Now, optical pumping, that is emitting energy in the form of photons, is used to raise the electron into a higher energy level. In this case, its energy level is E2. At a short period of time, the electron jumps into energy level E1 without emission of a photon. Consequently, the process of optical pumping cannot cause stimulated emission because there are two different amounts of energy present. The electron will maintain its energy level E1 for some time, then the atom will spontaneously emit a photon in a random direction as it relaxes to a lower electronic state. This photon may interact with an excited atom that hasn't emitted a photon yet. So, the photon hits the excited atom and causes a stimulated emission because the photon has the exact amount of energy to do that. Only photons emitted in a direction perpendicular to the mirrors will be reflected. The reflected photon initiates a chain reaction to produce more and more photons of the same kind. Furthermore, only photons with the same amount of energy and the same amount of atom will be part of the chain reaction. That's the reason why laser beams are strongly coherent and monochromatic. A very important aspect is the fact that many atoms must be in excited state for laser to work. More atoms must be in excited state than in lower energy states. This is called population inversion. To give you a clear visual example on how laser works, this is an experiment using motors, mirrors, and lasers. This presentation was made possible by the videos made by scientists Thomas Schwenk and Bryan. And that's all for this day's topic. Once again, I'm John Paul Alolor, and I hope you learned something.